Right now, think back to the last time you fell asleep, not waking up, falling asleep. Try to remember the actual moment it happened, the specific instant your conscious mind switched off and sleep took over. Chances are, you can't. You remember being awake and you remember waking up later, but the actual transition itself is almost always a complete blank. This happens to basically everyone, every single night, and yet it's one of those strange, universal experiences most people never actually stop to question. Why exactly can't we remember the moment we fall asleep? Let's dig into this properly, because the answer connects to some remarkably fascinating things happening inside the brain involving memory, consciousness, and the specific mechanics of how sleep actually gets initiated in the first place. Let's start with the most important foundational concept worth understanding first, because it reframes the entire question in a useful way. The reason you can't remember falling asleep comes down mainly to your brain generally not forming reliable, retrievable memories at all during that specific transitional window, rather than your brain failing to record the experience accurately and then simply losing that memory later. This is a subtle but important distinction. Rather than a memory of falling asleep existing somewhere in your brain that you simply can't access, in most cases that specific memory was likely never properly formed to begin with, which means there's nothing there to retrieve later, even in principle. To understand why this happens, it helps to understand a bit about how memory formation actually works during normal waking consciousness. So the contrast becomes clearer. When you're fully awake and alert, your brain is continuously encoding new experiences into short-term memory. And through a process involving a brain structure called the hippocampus, at least some of those short-term memories eventually get consolidated into longer-term, more durable storage. This entire process depends on specific patterns of brain activity and particular neurochemical conditions that are strongly associated with full wakefulness and active conscious attention. As you transition from wakefulness into sleep, your brain doesn't switch off instantly like flipping a light switch. It moves through a gradual, multi-stage process. And during this transition, the specific brain activity patterns and neurochemical conditions required for reliable memory formation start breaking down well before you're actually fully asleep. This means that even though you're still technically conscious and aware during the earliest moments of falling asleep, your brain's capacity to properly encode and later retrieve memories of that specific experience is already significantly compromised, well before sleep itself has even fully begun. Let's talk about the specific stages of falling asleep a bit more directly, because understanding this process in more detail helps explain exactly why memory formation becomes so unreliable during this particular window. Sleep researchers generally describe the earliest stage of sleep, often referred to as stage 1, as a light transitional state characterized by significantly reduced awareness of the external environment, along with sometimes strange, fragmented thoughts or imagery that can feel almost dreamlike, even though you're not yet in the deeper sleep stages typically associated with more vivid dreaming. This stage is notoriously brief, often lasting only a matter of minutes, and it's specifically during this stage that the transition from reliable wakeful memory formation to essentially no memory formation at all actually takes place. Here's the detail that makes this whole topic particularly interesting. People woken up during this very earliest stage of sleep often report having been aware of their surroundings just moments before, sometimes even reporting they weren't asleep at all, despite objective brain activity measurements clearly showing they had, in fact, already entered this earliest sleep stage. This mismatch between subjective experience and objective physiological measurement reveals something important about how blurry and gradual this transition actually is. Rather than a single, sharp, clearly definable moment where awake ends and asleep begins, it's a remarkably gradual, blurry transition, and your brain's memory-forming systems appear to lose reliable function. Somewhere within that blurry transitional zone, well before you'd subjectively describe yourself as having fully fallen asleep, in any conscious, deliberate sense. Let's talk about the specific neurochemistry involved a bit more directly too, because there's real, measurable biological explanation underlying this entire process, rather than it being some kind of mysterious, unexplained gap. As you fall asleep, levels of certain neurotransmitters strongly associated with wakefulness and alert attention, including norepinephrine and acetylcholine, begin declining well before you're fully asleep, while activity in brain regions specifically associated with reliable memory encoding, including the hippocampus discussed earlier, becomes significantly less active and less coordinated with the rest of the brain during this same transitional window. Since reliable memory formation depends heavily on this kind of coordinated, active brain function, and both begin breaking down before sleep, is technically fully underway. This creates a specific transitional gap where you were arguably still conscious in some meaningful sense, but your brain's memory recording function had already substantially degraded. This detail helps explain something that might otherwise seem contradictory. You're not unconscious the moment you fall asleep, at least not immediately. There's a genuine transitional period where some degree of awareness persists, but the specific neurological machinery required to reliably convert that awareness into a lasting, retrievable retrievable memory has already started shutting down, creating what amounts to a functional memory blackout occurring slightly before full unconsciousness technically arrives. Let's talk about a closely related phenomenon worth mentioning here too, because it helps illustrate this same basic underlying principle from a different angle. Anterograde amnesia caused by certain medications or substances, including specific sedatives and anesthetic drugs. Some medications specifically used for their sedative properties are known to interfere with memory formation while still allowing a person to remain conscious, responsive, and even apparently normally functional during that window. People under the influence of these specific substances can carry on conversations, perform simple tasks, and appear entirely normal to an outside observer, all while their brain simply isn't forming reliable, lasting memories of any of it, resulting in a complete blank when they try to recall that period afterward, despite having been conscious and seemingly functional throughout. This phenomenon offers a truly useful parallel for understanding what likely happens naturally during the transition into sleep every single night. Consciousness and reliable memory formation, it turns out, aren't the same thing, and they can become disconnected from each other under certain specific neurochemical conditions, whether induced by medication or, in the case of falling asleep, occurring as a completely natural, universal part of how the brain transitions into sleep on an ordinary nightly basis. Now let's talk about dreams for a moment too, because this connects to an interesting related question worth addressing directly. If memory formation breaks down as you're falling asleep, why can people sometimes remember dreams that occur later, deeper into the sleep cycle? The key distinction here involves which specific stage of sleep a person is in when a particular mental experience occurs, combined with what happens immediately around the moment of waking up. Dreams occurring during REM sleep, the sleep stage most strongly associated with vivid narrative dreaming, can sometimes be remembered, but generally only if the person wakes up directly during or very shortly after that specific REM period. The memory of a dream, in these cases, appears to get formed and briefly held in a fragile, short-term state right around the moment of waking, rather than being reliably encoded and consolidated the way an ordinary waking memory typically would be, which is a big part of why dream memories tend to fade so quickly and completely within just a few minutes of waking up if you don't make a deliberate effort to actively recall and rehearse them almost immediately. This detail actually reinforces the broader pattern already discussed throughout this whole topic. Memory formation during sleep and sleep transitions generally isn't reliable or robust the way waking memory formation typically is. Dream memories that do occasionally survive into waking awareness represent something closer to a brief, fragile exception tied specifically to the moment of waking itself, rather than evidence that memory formation is actually functioning normally at some point during the broader sleep process more generally. Let's talk about hypnagogia specifically, because this represents the formal term researchers use for the unusual, often bizarre mental experiences that can occur during this exact transitional window between wakefulness and sleep, and understanding it in more detail helps explain why this period is so cognitively strange in the first place, beyond just the memory issue already discussed. During hypnagogia, people sometimes experience vivid, fragmented mental imagery, strange, illogical thoughts that don't follow normal waking logic, or even brief, dreamlike micro-narratives that pop up and dissolve rapidly, all while technically still transitioning into sleep rather than being fully asleep yet. Some people also experience hypnic jerks during this period, sudden, involuntary muscle contractions, often accompanied by a brief, startling sensation of falling, which research suggests may be linked to the brain's motor control systems misfiring somewhat as they transition between different activity states during this unstable, rapidly shifting neurological period. This detail matters for understanding the memory question specifically, because it shows that a considerable amount of remarkably unusual active mental activity can occur during this transitional window, activity that under normal waking conditions would likely get encoded into memory without much difficulty. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. The fact that virtually none of this hypnagogic mental activity typically gets remembered afterward reinforces just how thoroughly and specifically memory formation breaks down during this period, since it's not simply that nothing interesting is happening for your brain to remember. Quite a lot can be happening, cognitively speaking, it's just that almost none of it survives as an accessible, retrievable memory afterward. Let's talk about microsleep too, because this offers another interesting related angle on the broader relationship between consciousness and memory formation. Microsleep episodes, brief, unintentional lapses in into sleep, lasting anywhere from a fraction of a second up to around 30 seconds, typically occurring when someone is severely sleep deprived or fighting exhaustion, illustrate a similar disconnect. People experiencing microsleep frequently have no awareness whatsoever that it even happened, sometimes continuing an activity like driving or performing routine tasks with their eyes technically open while their brain briefly slips into a genuine sleep state, then snapping back to apparent wakefulness with a complete blank regarding those lost seconds. This represents an even more extreme version of the same basic principle already discussed, a period where normal conscious function and reliable memory formation become disconnected from each other, except in this case, compressed into an extremely brief, involuntary episode rather than the more gradual, everyday transition into intentional nightly sleep. Now let's talk about sleep paralysis for a moment too, because it offers a remarkably fascinating counterexample worth examining. Specific sleep-related phenomenon that people actually do clearly remember afterward, which helps highlight by contrast what's different and unusual about ordinary sleep onset amnesia. Sleep paralysis occurs when a person becomes consciously aware while their body remains in the temporarily paralyzed state that normally accompanies REM sleep, preventing the body from physically acting out dream content. People experiencing sleep paralysis frequently report vivid, often frightening sensory experiences, sometimes including a strong sense of a threatening presence in the room, and these episodes tend to be remembered with unusual clarity and detail afterward, standing in pretty sharp contrast to the typical blank experienced around ordinary sleep onset. Researchers studying this specific contrast believe the key difference likely comes down to the fact that sleep paralysis involves a distinctly different, more fully alert form of brain activation, closer in certain specific respects to true waking consciousness, even though the body itself remains paralyzed compared to the considerably more subdued transitional brain state typical of ordinary sleep onset. This heightened alertness during sleep paralysis appears to allow the brain's memory-forming systems to function considerably more normally during that specific episode compared to how thoroughly those same systems shut down during a completely ordinary, uneventful transition into sleep on a typical night. This comparison is truly useful for understanding the broader topic because it demonstrates that memory formation during sleep-adjacent states isn't some fixed universal impossibility. It depends heavily on the specific type and degree of brain activation occurring during that particular episode, which is exactly why certain unusual sleep phenomena get remembered vividly while the completely ordinary, everyday transition into sleep essentially never does. Let's talk briefly about how this whole topic connects to broader questions about consciousness itself, because it raises a seriously interesting philosophical wrinkle worth at least touching on directly. If you can be conscious in some meaningful sense during the earliest moments of falling asleep, aware of your surroundings, capable of fragmented thought, but that experience leaves absolutely no retrievable memory trace whatsoever, it raises an interesting question about the actual relationship between having a conscious experience in the first place and being able to later know, remember, or report that you had it. Some researchers and philosophers studying consciousness have used exactly this kind of sleep onset amnesia as a useful, concrete example when discussing the broader distinction between consciousness itself and memory of consciousness, two things that feel intuitively identical from the inside in everyday waking life, but that this specific everyday sleep phenomenon reveals can actually become meaningfully disconnected from each other under the right neurological conditions. This is worth sitting with for a moment because it suggests something a little unsettling and remarkably thought-provoking once you really consider it directly. It's entirely possible that you have brief conscious experiences every single night that you will never, under any circumstances, be able to remember or verify happened at all. Not because they didn't happen, but because the specific brain machinery required to preserve any lasting trace of them simply wasn't operational at that particular moment. Your falling asleep experience tonight is happening right now, in some real sense, even though you'll never actually get to know anything about it afterward. Let's talk about individual variation in this experience too, because not everyone experiences this exact same complete blank regarding the moment of falling asleep. Some people occasionally report a vague, fragmentary sense of the transition, perhaps a brief awareness of thoughts becoming increasingly strange or disconnected, or a fleeting sense of drifting without anything resembling a clear, detailed, reliable memory of the actual specific moment sleep took over. This variation likely reflects natural individual differences in exactly how gradually or abruptly different people's brains transition through this specific process, along with differences in how much residual, fragmentary memory formation might occasionally persist slightly further into the transition for some individuals compared to others, rather than reflecting any single, universally identical experience shared by every single person without exception. Let's talk about a practical, everyday implication of all this too, because understanding this phenomenon actually helps explain a few other common, related experiences worth mentioning briefly. The reason falling asleep in front of the television and having no no memory of when the show ended, or dozing off during a long car ride and being unable to recall the specific moment your surroundings faded away, follow exactly this same underlying pattern. It's the identical basic mechanism at work every single time, memory formation quietly breaking down during the transitional window into sleep, regardless of the specific circumstances or environment you happen to be in when it happens. This also explains why people are frequently surprised by how much time has passed when they wake up from an unplanned nap, since the actual transition into sleep left no memory trace to help anchor their sense of how much time had elapsed, leaving them to rely entirely on external cues, like the position of the sun or a glance at a clock, to reconstruct roughly how long they were actually out. Let's talk about the developmental angle briefly too, because it's worth mentioning that this specific memory gap around sleep onset isn't something humans are born already fully equipped to reliably describe or reflect on. Very young children, still developing the neurological and cognitive machinery necessary for the kind of detailed self-reflection required to even notice and describe a phenomenon like this in the first place, generally don't spontaneously comment on or seem to notice this particular memory gap the way older children and adults typically do once they become capable of that kind of detailed introspective reflection on their own mental experience. This suggests that noticing and being puzzled by this specific phenomenon at all requires a certain baseline level of cognitive and introspective development layered on top of the underlying neurological mechanism itself, which begins operating from a much earlier age, well before a child would have the cognitive capacity to actually notice or comment on it directly. It's also worth briefly mentioning how this specific phenomenon compares to general anesthesia, a topic that shares some truly interesting structural similarities worth a quick mention here, even though it deserves its own separate, more detailed exploration. Both involve a transition from ordinary waking consciousness into a state where memory formation becomes unreliable or completely absent, but the underlying mechanisms, timeline, and depth of that disruption differ considerably between natural sleep onset and anesthetic-induced unconsciousness, given that anesthesia typically involves a much more abrupt, medically controlled, and complete disruption of memory formation compared to the considerably more gradual, natural transition your brain goes through every single night when falling asleep on its own. Let's talk about how researchers actually study this specific phenomenon too, because it presents some fairly significant methodological challenges worth appreciating, since the entire point of the phenomenon is that people don't reliably remember this specific transitional period. Researchers can't simply ask people to accurately describe their own experience of falling asleep after the fact, since that method runs directly into the exact same memory limitation being studied in the first place. Instead, researchers rely heavily on real-time physiological monitoring, tracking brain activity through EEG measurements, alongside carefully timed awakenings during specific, precisely identified stages of the sleep transition process, comparing what the objective physiological data shows was actually happening in the brain against what a person subjectively reports experiencing or remembering when woken up at that exact carefully controlled moment. This research approach has been essential for building the current scientific understanding of exactly when and how memory formation actually breaks down during the transition into sleep, since it sidesteps the core methodological problem of trying to directly ask people to reliably remember something specifically located within the exact experience being studied. Let's zoom out and pull all of these different threads together, because the full explanation for why we don't remember falling asleep turns out to be considerably more specific and mechanistically grounded than a vague, mysterious sense that sleep is just naturally forgettable. The transition into sleep involves a gradual breakdown of the specific neurochemical conditions and coordinated brain activity patterns required for reliable memory formation, a breakdown that begins before you're technically fully asleep, creating a functional gap where a degree of consciousness may briefly persist, but the brain's capacity to properly encode and later retrieve a lasting memory of that specific experience has already substantially deteriorated. Rather than reflecting any flaw or malfunction in how your brain works, this amounts to a predictable, well-documented consequence of how memory formation and the transition into sleep happen to overlap and interact within the brain's ordinary, everyday functioning. So the next time you find yourself wondering once again exactly how you ended up asleep without any memory of the actual transition, it's worth appreciating that this reflects a universal feature of how human brains are built, rather than some strange personal quirk or a sign that anything unusual happened. A brief, nightly window during which consciousness and reliable memory formation quietly, predictably part ways, well before sleep itself has even fully arrived, occurring identically inside virtually every single sleeping brain on the planet, every single night without exception. It's worth adding one final practical note before wrapping up, because it connects this whole topic back to something almost everyone has direct personal experience with: the strange, sometimes unsettling sensation of trying and failing to pinpoint exactly when you fell asleep during a long flight, a boring meeting, or a quiet afternoon on the couch. That fuzzy, unplaceable gap reflects reflects the direct, predictable result of the exact neurological process described throughout this entire topic, rather than any failure of attention or sign of poor self-awareness playing out in miniature in whatever ordinary setting you happened to doze off in that particular day. Which leaves an interesting thought worth sitting with. If something as basic and universal as falling asleep involves this much complexity hiding beneath a completely ordinary, everyday experience, quietly disconnecting consciousness from memory formation every single night without you ever noticing it happening in real time, what other completely mundane, unremarkable daily experiences might be quietly built on a similarly intricate, only partially understood foundation of underlying brain mechanics that we simply never think to question?